Hi everyone, this will be a video on how to write an equation of a tangent line, but using a problem that requires implicit differentiation. So just remember that implicit differentiation is needed when you have x's and y's in your whole function. Notice that they're only giving us an x value. I'm going to need the rest of that point, so we can always just find it right now. So first, we'll call this step one. Step one, we're going to find y coordinate of point. Okay, so they're telling us that x equals -1. So when I'm looking at my problem, I can plug in -1, so I would have like 3 times -1 squared. I will just leave my y's the way that they are. And I plugged in -1. So from here, I'm going to have 3 times 1 plus 2y equals 1y. And it's telling me that 3 plus 2y equals y. We can subtract our 2y, so we're going to have 3 equals -y, so -3 is going to equal our y. So our whole point is going to be -1, -3. We're going to come back to this, so I definitely want you to put a box around it, highlight it. This is the point that we're going to be concerned with. Alright, so let's move on to step 2. So step 2 would be to find the derivative implicitly. So we're going to find derivative implicitly. Okay, and what that means is we're going to take the derivative of x's and y's. Just remember that every single time you take a derivative of a y, you need a dy dx. So our function was, I'm just going to write it down here so we have it again. So we have 3x squared plus 2y equals x squared y. So we're going to be finding the derivative here. So when we're looking here, our first term, I'm going to skip a little space here. So here we go. So we're going to have 6x, that's it, that one's good, plus 2, this one needs a dy dx, equals, now to get the derivative of this right hand side, we have to see that we have 2 things being multiplied here, and we practice something called the product rule a lot, and that's for when we have 2 things being multiplied. So we need our product rule. To get that set up, we'll do our f of x equals x squared, g of x will equal y, f prime, we get 2x, g prime, we would technically get a 1, and then it's a dy dx, so you can just write dy dx and understand it's just 1 dy dx. So now when we're using our product rule, remember it's f prime times g, so we're going to have 2x times y, and then we're going to add g prime times f. So that's just really going to be an x squared dy dx. Okay, so now we just need all terms that have dy dx on one side and all terms that don't have it on the other. So I'm going to subtract a 2xy, subtract a 2xy. I'll also add a 2 dy dx, and I'll add another 2 dy dx. So my left-hand side, these are going to cancel. Oh, I should be subtracting that. Let's fix that real quick. Subtract. Alright, so these will cancel because I had a plus 2 dy dx minus 2 dy dx. So my left-hand side is 6x minus 2xy equals, now my right-hand side will be, this cancels, and I'll be left with x squared dy dx minus 2 dy dx. Okay, from here, we can group our terms. If they're grouped, we want to factor out. So we have 6x minus 2xy equals dy dx times x squared minus 2. And we want that dy dx by itself, so we're going to divide both sides by x squared minus 2. We're going to divide our left-hand side by x squared minus 2. Cancels out on the right-hand side. On the left-hand side, you can leave it how you see it. So we have 6x minus 2xy over x squared minus 2, and this is what our derivative equals. So we really need to always remember that the derivative, the value of this is the slope of the tangent line. Okay, so that's kind of like what we're always thinking back towards. So if I can plug in my values here, I can get the slope of my tangent line, and then from there I can use my point and slope. So that's going to be our step 3 here. So step 3, evaluate dy dx with given point this will be our slope. So our point was -1, -3. Our dy dx was, it's still on the screen, we have 6x minus 2xy over x squared minus 2. And we're going to plug in these values. So dy dx equals, we're going to have 6 times -1 minus 2 times -1 times -3 all over -1 squared minus 2. So simplifying little bits at a time, we end up with -6 minus 6 all over 1 minus 2, which is -12 over -1, and we get 12. So we have our slope. It's right here, okay? So our slope is 12, we have a point, so that's going to be our step 4, is to use point slope form. Okay, so you're going to use slope found in step 3 and point given in point slope form. So write equation. So you do want to be careful if this is on Delta Math. They might even ask for your solution in point slope form. You might not have to simplify. So if you forget it, it's y minus y1 equals m times x minus x1. Our point was -1, -3. And our slope we found in step 3, which was 12. So when we're getting this set up, it's going to look like y minus -3 equals 12 times x minus -1. And then you just want to simplify anything you can. So this is really like y plus 3 equals 12 times x plus 1. Now, if your question's asking for your answer in point slope form, this is it. If your question is asking this for in slope intercept form, you just have to do a little bit of rearranging. So this becomes, let me just box this off. You know that this is a good answer. If you're asked for slope intercept, you have to subtract 3. And you also have to distribute. So we really have 12x plus 12 minus 3. So we would get 12x, oops, forgot the x there, 12x plus 9. So this would be something that would be in slope intercept form. So it all depends on what they're asking you, how they want you to type in your answer. But just know that you can get to slope intercept right from point slope form.